Well, I'm going to call this video an introduction to SPSS. Hopefully, you guys are familiar with some of the stuff based on our class discussion, but I know it takes a while to really get comfortable with SPSS. So I'll do some intro stuff. I'll probably do some pretty simple analyses in this video. So SPSS, usually here you're going to be opening up files which have data in them. By the way, you always can open up a new file. And I'm using two windows, so it popped up there in the other window, and I moved it over here. But literally, you can start with a blank file and start typing data in, which is what you'll do for your project. Just remember, you have two views. You have variable view and data view. Let me go back to my full data set here. This is customer data, which is out on EduCat. Data view shows you the variables and shows you the values for those variables. And variable view shows you the name of the variables and some information about it, right? This stuff does not magically appear, by the way. You may think that based on class, but actually when you create a data set, you usually have to put most of it in. And so keep that in mind. If I were to create a new data set here, and maybe I have, let me go to create a couple of variables. I have, let's say, age and salary and whether they're married or not. I always do that, by the way. SPSS is very picky. It does not like question marks. It doesn't like spaces. And it's kind of annoying, but it is what it is. So I have three variables I'm going to put in here. Age, we know what that is. That's going to be a scale. Scale is interval or ratio. It's ratio, obviously. Same with salary, which is ratio. So that's scale. Married it's going to be nominal. I always try to make those correct. It's helpful. For age and salary, something like that, you can also put in a longer label. I wouldn't, or I just put in the names again, or not put anything in. They're pretty self-explanatory, but you can put in a longer explanation if needed. Something like married, it actually makes sense, since that would be, if you're going to put that in as 0 1s, explain what it means. Because you could code your 0 as not married, you could code it as married. Just having 0 1s don't tell you a whole lot, but if you code it like this, and okay, anyone looking at your data set can see this. So they may look at your data, and I haven't put anything in here yet. Let's put some people in. 36. We have a 42, a 56-year-old, an 81-year-old, a 23-year-old, an 18-year-old, right? And their salary, we'll just make up some numbers real quick. 81-year-old, we're assuming, is still working. Maybe they wouldn't be. 18-year-old, probably a part-time job. Yeah, 15,000. Anyways, whether they're married or not, this person is, this person is, this person is, this person is. No. But if you just see data like this and you see married, I would tend to assume 1 means they're married and 0 means they're not. But someone could code either way. So it's a good thing about putting here in variable view if someone else is using your data or you're using it later. Just show you that it's easy to just create a new data set in SPSS and type data in. Just create new variables here, and once you do that, you can type it in here. I'm going to get rid of that and go back to our customer data. And we used this in class before. It's a mail order company. They have data on their customers, how much they spent last year, all that good stuff, right? So in SPSS, really what we're going to use is, there's a lot of cool things you can do in SPSS. We're going to use the file menu basically to save and maybe open a new file if you want to type some data in. The edit we're not going to use a lot. You can copy and paste and stuff like that, which I do occasionally. View, do not use a whole lot. Data is actually really useful. You can manipulate and restructure the data, but it's going to be all what we're going to do. Transform and analyze are really the things that we'd be using. If you want to compute a variable, if you want to take 4 questions which are measuring entrepreneurial intensity or environmental consciousness, and assuming those questions are on, the responses are on a Likert scale or something like that, or a numerical scale, which you can assume are interval, you can sum those things together, and you would use a compute variable to do that. It basically allows you to do any mathematical manipulation you want to on variables. So that's pretty cool. The other thing you use are recodes, and usually recode into different variables, such as on your homework assignment, right? Where you wanted to recode, we have a variable how many children people have. If you want to recode that into a dummy variable, 0, they have no children, 1, they do have children. Now, honestly, you're usually not going to do anything like that because you're throwing away information. But, you can if you want. I could do the same thing with age. I could take their age and I could create a dummy variable for old. So if you're over 65, and hey, let's do that. It'll be fun. I can take age, and I'll call this variable old person. Hopefully I'm not offending anyone. There's nothing wrong with being old. We all get there eventually, typically. The old and new values. This is kind of interesting because I have a lot of possible values. And I don't actually remember the oldest person in the data set that I have here. So I could, the way we've done it is, you recode 1 value at a time. You can actually put ranges in, which is what we might do. Which is what I'm going to do in this case. I'm going to say if you're 0 through 64, you get a 0 because you're young. And I think this will work. If I put 65 and no max value, it will take 65 or greater. We'll see. No, it didn't like that. All right. If you're 65, I know there's like no really 120. No one's older than that. Make that a 1. And all right. That'll work. And it always puts new variables at the very end. Or if you go to a variable, well, you see them right here. I'm going to move it. And to move variables around, it's really easy. If you're in the variable V, you just kind of click on it, and you drag it. I'm going to drag it to be close to my age variable so I can compare. Go back to my data. You see anyone over 65, 73-year-old gets a 1. 69-year-old got a 1. The 71-year-old got a 1, etc. So I could do that. In reality, I'm probably not because I'm throwing away information. But maybe I think that, there's some sort of effect where age doesn't really impact spending until you get above a certain age. Then maybe I would. There's actually other, probably better ways to do that, but this would be one way. All right, I'm going to delete my old person variable. I will use it. Oops. Uh-oh. There we go. All right. So that's transform. Analyze has all the stuff we're going to use for analyzing data. And there's a ton of things you can do in here. You can do descriptives, and honestly, sometimes I don't remember exactly how to do what I want to do. Okay, so sometimes I will fumble around in class or on a video recording maybe, thinking, okay, I want to do this. How do I do this? I actually find the descriptive menu in SPSS a little not extremely intuitive. Usually you are going to be doing frequencies, descriptives, explore, or crosstabs. Frequencies you commonly use if you want to look at a variable with a fixed number of categories, right? I'm going to run a frequency on age and just let you see why this is not a good idea. It actually shows me, and this is the result, 750 people, one missing. It shows me how many people, and this actually isn't too bad, but it shows me 21, there's 19 people, that's 2.5% of the sample. For 22, there's 16, that's 2.1% of the sample. Cumulatives are running total of what percent of the sample. You see, once we get to 76, which is our oldest person, we have 100%. So this might be okay, but to me it's hard to really analyze because you have so many categories. Where this is more useful is the case we have a fixed number of categories. And this could be the case where we have some sort of dummy variable, or even something like number of children, where we're probably not going to have people with over 10 or many people over even 5. So let's rerun frequencies. I'm going to take age out and put own home, and also put children, and it will actually run on both. For own home, you actually get the frequencies. For don't own home, does own home. More people actually own a home than don't own a home. It's about 52 to about 48%. That's pretty useful. For children, it's pretty useful too because there's not that many categories. There's 0, you don't have children, which is about 45%. About 28% have 1, about 15 have 2, and about 12 have 3. So that's where you use frequencies. Close this. Then there's descriptives. Descriptives are useful in certain cases. They're used to calculate means and standard deviations, and really useful when we're talking about data where it makes sense to calculate means and standard deviations. Things that are, I think I did something. Yeah, there we go. Things that are interval or ratio, things that are true numbers. This might be interesting, like age or salary. There's options. Again, it's popping up into their screen because I have two open. It usually gives you what you want, mean and standard deviations are what we look at the most. Some of you might want to look at the range, so I'll click that. Click OK. And we get our descriptives for both, for age and salary. Range of 55, minimum 21, max of 76. For salary, you see even bigger range, minimum of a little over 10,000, maximum of 140,700. You see the mean for age, about 43 years old. Mean for salary, almost $56,000, and we get standard deviation for both. And there's quite a bit of variability in both variables, which makes sense. So that is descriptive. And that's pretty much all you can do with descriptives. It's very simple. A lot of times I go to descriptives wanting to do other things, and you can't really do it under that. It's a very simplified option. Explore is kind of like descriptives, but it allows you more options. And so there's a couple things you can do under Explore. And we use this in class. If you remember, we talked about, I forget what it was offhand, but I did some sort of hypothesis test and then a confidence interval. I think confidence interval is what I did using this menu. Let's just look at salary, right? And let me go to statistics and descriptives and confidence interval. And you can't put factors in. I'll show you that in a minute. That's actually pretty interesting, but we're not going to do that right now. I think if I want to use salary. Yeah, let's use salary. So it gives me a mean of $55,988 if I round, and gives me a median, which is less. Makes sense. There's a bit of a right skew to the data, standard deviation, etc. All that stuff we got before when I just went under descriptives and descriptives. But it also gave me confidence intervals and gives me a lower bound of 53,848 and an upper bound of 58,127. So what does that confidence interval mean? Think if you can interpret that before I tell you how to interpret it. Okay, first of all, for constructing confidence intervals, the assumption is that we have a sample. In this data set, there's 750 customers, right? If that's our entire list of customers, or it's really, really close, we're not going to construct confidence intervals. Because if we have the population, we have a mean of $55,988, and that would be our population mean. End of story, done. But presumably these 750 customers are a sample, maybe out of 100,000 or 200,000 customers. If that's the case, we may want to make an inference. And yes, we have a sample mean of $55,988 in salary, but that doesn't mean that if we had the entire population of all our customers, that we have something exactly like that. So what the confidence interval is telling us is we're 95% confident that the population mean salary for our customers is between $53,848 and $58,127. Right? It's actually a pretty wide range that the mean salary for our customers could be from. And we might be curious about, hey, what really is the salary of our customers? How high income people are buying from us. So that could help kind of clarify this a little bit. So with that, that's how you can do confidence intervals, is actually using the explore function. Another thing you can do with this is you can create a factor list here, and let's look at whether they own a home or not. And if you do that, it actually breaks it down, which is kind of interesting. The mean salary for someone that doesn't own a home is $42,468 in a sample, and then there's some confidence intervals for that. And then if they don't own a home, the mean, at least in the sample, is $68,400. Actually a pretty big difference. Of course, the confidence interval suggests that we would see a difference in the population as well. All right. So the other option that we might use is crosstabs, and that's if we want to look at some sort of relationship between variables. If we're looking at two variables, usually things that are nominal or ordinal that have a limited number of categories. So if we wanted to see, hey, what's the relationship between owning a home and being married, or how many children someone has, like you did on your homework. If you do that, you get something like this, where it actually puts everyone in a table, and you see we have married on top and own home kind of on the left. And you can see where everyone fits in this table. And see if there's some sort of relationship between the two. I actually don't use this a whole lot, but it is, if you just want to look quick at a relationship between two variables with a fixed number of categories. All right, so that's the intro video, and I'll also make some other videos that will kind of build on what we talked about here.